if we just want to talk about some other limits at infinity, or just finding horizontal asymptotes, remember that's the same thing as finding the limits at infinity. So for example here I've got the absolute value of x divided by x plus 1. So if you recall from some previous work that we did or from your algebra classes, the absolute value of x is equal to the face value if x is greater than or equal to 0, or negative x if x is less than 0, because that's what would make it positive. So our f of x, which is equal to the absolute value of x divided by x plus 1, would be equal to x divided by x plus 1 if x is greater than or equal to 0, and negative x divided by x plus 1 if x is less than 0. So one thing that is important to note is that f of x does not exist if x plus 1 equals 0, so x equals negative 1 is going to be a vertical asymptote. So I'm going to go ahead and mark that on my graph just so I don't forget. Vertical asymptote here. Now I want to find the horizontal asymptotes, which I will need for my graph. So I'm going to have y equals the limit as x approaches infinity of f of x. And as x approaches positive infinity, those are definitely going to be numbers that are greater than 0. So this is the limit as x approaches infinity of x over x plus 1. Notice they have the same degree, so that's going to be 1 over 1, or 1. So we have a horizontal asymptote at y equals 1 on the right. The limit as x approaches negative infinity of f of x, well, those are definitely going to be values that are less than 0. So this will be the limit as x approaches infinity, or negative infinity, sorry, of negative x over x plus 1. So this ratio is going to be negative 1 over 1, or negative 1. So on the left we have a horizontal asymptote at y equals negative 1. So we know at some point over here we're going to have a horizontal asymptote here, and some point over here we'll have one down here. We do need to figure out some extra points, so I'm just going to plug in a few points into my graph, or into my equation. So you can see that I've just plugged some x values in and found the y value that goes with them, and I've plotted them on the graph. So at this point we want to kind of follow the pattern. It looks like this one is going down to the right towards the asymptote and up towards this asymptote right here. And on this side it looks like we're going up towards the vertical asymptote. And over here we've kind of come down to 0, and then we're going to kind of bounce back up towards the horizontal asymptote. So that ends up being a good approximate sketch of my graph. And we do have the horizontal asymptotes at y equals 1 and y equals negative 1. Limits of trig functions can also be interesting. So one thing that you can always go back to when you're looking at this is a graph. So I want to find the limit as x approaches infinity of sine of x. But the thing about sine of x is that it has that repetitive pattern. So it's going to repeat the same curve over and over again forever and ever, basically. So you notice that it's never going to stop going back and forth between 1 and negative 1. So this limit actually does not exist, because sine of x will always oscillate from negative 1 to 1. It's not going to approach a single number L. However, if you wanted to find the limit as x approaches infinity of something like sine of x over x, you could actually do that. So remember we had a theorem called the squeeze theorem? So sine of x, we know, has to be between 1 and negative 1. That's how its graph works out. It always goes from negative 1 to 1. So if I were to take all three pieces of this and divide by a positive x, which we can do since we're approaching infinity, we know it's not going to be 0 or negative. That gives me that sine of x over x is between negative 1 over x and 1 over x. And we know that the limit as x approaches infinity of negative 1 over x is going to be 0. And the limit as x approaches infinity of 1 over x is also going to be 0. We get that because it's a c over x to the r. So the squeeze theorem says that the limit as x approaches infinity of sine of x over x is also equal to 0. And you can get a graph of that and verify that pretty quickly, but that is the answer. So sometimes you can evaluate limits at infinity of trig functions that are being manipulated in some way like this, but in general the normal trig functions, because of their periodic nature, don't have limits at infinity.